So this is the derivative of the first, is 6, x squared plus 3 to the minus 2 plus 6x times negative 2 times the blob to the negative 3 times the derivative of the blob. So we know that's correct. So 6 x squared plus 3 to the negative 3. So that's going to give me an x squared plus 3. I'm taking a 6, which leaves me a 4, x squared and that. So that looks right. The problem I'm having is that I've got a 3 minus oh, I'm okay. Dang it. 3x squared. I'm fine. And so what I have is 6 times 3 minus 3x squared over x squared plus 3 cubed. And so we're going to set that equal to 0. Now the only way that this can be 0 is if 3 minus 3x squared equals 0, or minus 3x squared equals minus 3, x squared equals 1, or what's x? Plus or minus 1. And their multiplicity 1. Now, since their multiplicity 1, that means that plus or minus 1, they are inflection points, because there will be a change of sign across. Yes?
I'm just a little confused on their steps. Can you explain why in step 2 up there, the negative 2 exponent changes to a negative 3 in the first term?
Because remember when you do the derivative, you drop it a power?
No, not that one, but you change it below that one in the first.
She's pulling out the negative 3 power.
I'm pulling out an x plus 3 to the negative 3. That's the smallest power between these two.
Oh, I see. Okay.
Right. Plus or minus 1, which I know is the right answer. Whew. So that then on my number line, I have negative 1, I have 1. So I can choose x equals 0 as a test. It's a change across, so I know they are inflection points. So I need to go back to the original problem, which I even forgot what it was, or no, back to the derivative, and put in 0. So if I look at 6 times 3 minus 3x squared over x squared plus 3 cubed, this denominator, no matter what number I put in, is a positive number. If I put a negative 1 in, I square it. Square plus positive is positive. Positive cubed is positive. It goes the way of the numerator. So if I put 0 in, I'm going to get a positive 18. So it's positive here, negative, negative. So concave down, concave up, concave down. So concave up from minus 1 to 1, concave down from minus infinity to minus 1 to and 1 to infinity. Inflection, minus 1 and 1. And now I even forget what the original problem is. So let's take a look at what f of x is. F of x was equal to 6x over x squared plus 3. So that f of 1 was 6 over 4. 6 over 4 is 3/2. And f of -1 is -6 over, well, same thing, 4, only the opposite number. No, it should be the same number, shouldn't it?
I think he used the derivative. Because it was 1/2 over, or x squared over x squared plus 3. That's the original problem.
It's a square.
And there's no,
That's why it doesn't that's why it matters.
and there should be no 6. So it's just x squared over x squared plus 3.
That's why you end up with the same number. So this would then be a -1 squared. And you're going to end up with a positive 3/2. Because it's 6x. Oh,
There should be no 6. You use the derivative.
where'd I get the 6 from?
The derivative.
Derivative. See, that's not where I had my problem in the first hour. So that's going to be, yeah. Now you see a full video of me taking stuff out. So this is now 1/4. At least this is working. First hour, the derivative killed me. I got through the derivative just fine. Here.